we have already gone into the digital electronics, what we will going to see today is that what are the basic notations that we are using in the digital electronics. So one of the basic notation that we are using in the digital electronics are the number system, that how we will going to make our information in the form of zeros and ones, and how we are converting all the information, whether it is our speech signal, whether it is our image signal, or whatever the signal, even if I'm writing on a pad, so how this pad signal is being transmitted into the system of a computer, and whenever I'm transmitting my voice, how it will going to be transmitted. So today what we will going to do, we will going to discuss about the number system. So whenever we are talking about the number systems, so number system means, okay, as the name suggests, number. So how we have to represent our data, in which format we have to represent our data, our information. So therefore the name, it is written as the number system. So what can be the numbers we are using? For example, if we talk about the cricket, so we have got a nomenclature that player at number 0, player at number 1, opening batsman, third down, fourth down. I hope you have gone through the cricket match and you are aware of this. So what we are doing, we are setting the number system. In a similar way, what we are doing when we are talking about the digital electronics, we are talking about the number system. So when we are talking about the number system, we are dividing our number system into two parts. First thing is, when we are talking about the number system, is when we are talking about the weighted code. Weighted code you can understand like this. Let's say again I go to the cricket example. We have got a set batsman that this will be our opener, this will be my first down, this will be my second down. So what we have done, we have assigned a weight to the player. What can be the unweighted? Randomly betting, yes, definitely randomly betting. Or we can say that when you are not providing any particular weight, someone, suppose at the opener we were expecting that it will come on the as a opener, but it is not coming as a opener. So what we are saying, we are not have got the weighted, particular weighted. So these all code which we don't have assigned a particular number to it, that will come into the unweighted, no position. Okay, so this thing is clear to you, weighted and unweighted. So when we are talking about the weighted, we have got a weighted number system like binary, octal, decimal. So octal number, decimal, hexadecimal, and finally we have got our BCD. Okay, BC. So when we are talking about the binary, what does binary means? So we can say binary means your 0 and 1. When we are talking about the octal, octal means 8, 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. If we talk about the decimal, what will be the decimal? Starting from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when we are talking about the hexadecimal, what can be a number? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, what we have got? We have got 10, 11, 12. So hexa means 16. We have total 16 number representation. Okay, so we will be using the, after 10 we are using the A, B, C, D, E, F. If I take this here, how many numbers I am representing? 0 and 1. Means I have a base or radix, we can say we have got 2 numbers. If we are talking about the octal, how many? We have got 8. And when we are talking about the decimal, how many numbers we have got? We have got 10. And when we are talking about the hexadecimal, how many numbers we have got? We have got 16. Yes. Then we have got the BCD, that stands for the binary coded decimal codes. And one word is here, coded. So it has got this importance that how you will going to code your number. Okay, we have got a different weights of a number, so we can arrange a systematic arrangement of a weight of a order, and then we can find out the weighting of the numbers. Okay, so therefore it is named as the binary coded. That means we will going to code the number, how 10 will going to be represented, how 8 will going to be represented, how 2 will going to be represented. Then we have got a unweighted codes. So whenever we are talking about the unweighted codes, codes are your gray codes, gray code, and your axis 3 code. Okay, so this number system is clear to you, that the number system, we are dividing the number system into the weighted number system and unweighted number system. So in weighted number system we have got binary, octal, decimal, hexadecimal, BCD, and in unweighted code we are defining it as gray code and axis. Now we will be talking about the binary numbers. Okay, so how we will going to represent our binary numbers. So before understanding that binary numbers, let me talk about the decimal. So whenever we are talking about the decimal, okay, if I ask you, can you identify a decimal number? If I write here, let's say 7392. So can you tell me whether it is an octal number or a decimal number? Decimal number. Why you can say it is a decimal number? So it has got a number representing from 0 to 9. That this decimal number has a numbering starting from 0 to 9. That means we have got 10 numbers, and therefore the name is deci. So how we will going to represent this decimal number? So whenever we are representing any of the numbers, we are using a series coefficient. Series coefficient means how we will going to represent the number. So always what we are doing, we are representing a series coefficient with the aj. And what the value of j will be? Your j will be lying between 0 to 9. So whenever we are talking about the decimal number, so how we can write? We can write a series of coefficient. How we can write a series of coefficient? Like let's say we can write a starting from 0, then we can write a1, we can write a2, we can write a3, we can write a4, we can write a5, and so on. How many we can write? We can move till 9. And after this we can use a dot notation also. We can use a dot notation. We can write another term in the form of a minus 1, a minus 2, a minus 3. Okay, so what it is represent? It is representing your decimal point. And you all know, when we want to add a series coefficient, what we have to do? We have to do the addition. So what we are doing? We are representing a series coefficient like aj, and the value of aj will be between 0 to 9. So let's say if I want to provide, I want to provide a series coefficient of decimal. So how many number we have got in decimal? We have got 10 number. Okay, so how we will going to do this? In the form of addition. We will go in the form of addition like this. What is the base of this? 5. So I can write 10 raised to power 5 into a5 plus, what is the base of this? 4. 10 raised to power 4 into a4 plus 10 raised to power 3 into a3 plus 10 raised to power 2 into a2. Okay, and then plus 10 raised to power 1 into a1 plus 10 raised to power 0 into a0 plus 10 raised to power minus 1 into a minus 1 plus 10 raised to power minus 2 into a minus 2 plus 10 raised to power minus 3 into minus 3. So whenever we are talking about the series coefficient, okay, so let me come to the basic which you learn in your class 1, 2, 3. But if I am saying 392, okay, let's take this 392. Now if I ask you, can you tell me that how you will going to write in the power of 10? So how you can write? The 9 is present at the place of 10, where the 3 is present at the 100, where the 2 is present at 1. Okay, it's clear now? Let me come back. Okay, so this is the your ones place, ones. This is your tens place. This is your 100. Now if I talk about ones, what ones means? 10 raised to power 0. What tens means? 10 raised to power 1. And what 100 means? 10 raised to power 2. So can you represent 392 this is the coefficient, and if I want to represent in the addition form, so how you will going to represent it? You will going to represent it like this: 3 into 10 to the power 2 plus 9 into 10 to the power 1 plus 2 into 10 to the power 0. And what you get? 300 plus 90 plus 2. This will going to give you 392. Now if I want to represent, let's say, come to again this 392.5. If I ask you, what is this 5? At which position this is present? 10 raised to power minus 1? Yes. So you can see that when I am talking about this a minus 1, where it is present? It is present at a raised to power minus 1. When I am talking about 0, where it is present? It is present at the 1 position. When I am talking about 1, it is present at the 10 raised to power 1, that is 10th position. When I am talking about a2, it is present at 10 raised to power 2, that is 100th position. See, when you are defining the series coefficient means that you have the series of number which you will going to add. Okay, so therefore it is known as a series coefficient. So now what we can do, we will going to take this number again 7932. We will going to see what is the position of this 2, a0. Then what is the position of this a1? What is the position of this a2? And what is the position of this 7a3? Now if I want to write this series, I can write a series in this form. I can write this. What is the 3a3? What is the coefficient here? a3. We have this a3 coefficient. What is the number place we have got? 10 raised to power 3. So I can write 10 raised to power 3 into a3 plus 10 raised to power 2 into a2 plus 10 raised to power 1 into a1 plus 10 raised to power 0 into a0. Now what is the value of a0? So the value of a0 is right now here is 2. What is the value of a1? The coefficient value is 9. And what is the value of a3? a2, that is 3. And what is the value of a3? It is 7. So I will going to put this value here. So I will going to put 10 raised to power 3 into 7 plus 10 raised to power 2 into 3 plus 10 raised to power 1 into 9 plus 10 raised to power 0 into 2. Okay, so what will be the answer? 10 raised to power 3 into 7 will be your 7000. 10 raised to power 2 into 3, 300. 90 plus 10 raised to power 0 means 1. 1 into 2, 2. What will be your answer? 7392. This will be your answer. Right now, if we are talking about this decimal number, so we have got a base or radix. What is the base or radix? Right now we can say the base or the radix of a decimal number was 10. And because we have used 10 digits and the coefficient are being multiplied by the power of 10. Okay, so the radix of a decimal is come out to be your